This is Russ Anderson. One of your tasks, if you're inserting objects into a live action shot, is to match the lighting. Now, SynthEyes has tools out on the 3D panel that let you determine the direction and even the position of lights in the scene if there are suitable features that can be tracked, and that would be a feature and the shadow of the feature as well. But in this particular tutorial, we're going to be concerned about lighting changes that happen over the course of the shot, and that's due to something like an explosion or some strobe lights or a flickering campfire or maybe a vehicle that drives into the scene at some part. So the lights themselves are changing, and we want to be able to reproduce what's happening. And as another thing that we can cover, that's a situation like this where due to the orientation change, there's a very dramatic shift in the coloration of this mesh over the course of the shot. So you could try and exactly reproduce what the lighting is and what the properties of the material are and get that to exactly match. Or you can maybe try and measure it the same sort of way, and that is what this particular tutorial is about. So one thing just to point out that's relevant to this is just if you hold down the control key and look down in the bottom left corner, you'll see that you've got the color values. So, in something like this, you can look at the color values at the beginning and end of the shot and see, they've changed rather dramatically. And what we're trying to do is get the exact curve of how those change over the length of the shot. So our particular shot here is one that I have already tracked. And you'll see as I scrub through this, you see the moving object and the trackers are on it. And I used a couple of those to set up a coordinate system. So this is the starting point for this exercise. And we'll jump over to the trackers panel, and I'm just going to hold down the C key to create a tracker. And you can look in the interior of the tracker and see it's relatively homogeneous. That's what we're looking for, so that we can measure the color that's there and drive that into our downstream application. We don't want something like this where something else comes into the field of view of the tracker and is going to throw off that measurement. So we want something that's nice and a clean color value. And just maybe we'll make it a little smaller to start with there. So that's great for a measurement standpoint, but for actually being able to track it, we're tracking something that's a blank wall, and it's not going to go well. The tracker's just going to wander off because there's no detail to track. So one way to deal with that is to use the offset tracking capability, and we just track something else here, there, and have an offset up to the actual tracker location that we want. And that's pretty straightforward. But for this particular tutorial, we're going to do something a bit different that kind of segues into the rest of the tutorial. So that's what I'm going to show here. And to start out with that, we're going to jump over to the perspective view, and we're going to select those trackers that I used initially to set up the coordinate system, and select the add card mode. So that's just going to let me sweep out a card on the face of this box using those guys as a reference. And I'm just hit backslash to go to wireframe mode. So now let's go back to the, I'll go to the 3D view and just point out that because we had object 01 selected when we created the object, it is parented to it, so it's now moving along with the object nicely. So that's good. And now we can go back to the tracker view just to be more clear, and we're going to do a drop onto mesh. Okay, probably be better if we select the tracker. We want to do that, so that's our tracker that we have created. So we just created this 3D location that's on the surface of the card, And if I do a Shift 5, that says automatically pan to follow the 3D location, that seed point location I just created. So if I do that, you can see that we're following exactly where that 3D location goes, and it's staying right at the point that we want to measure. The tracker itself goes wandering off into the distance because we haven't done anything for tracking with it. So for the purposes of our color measurement exercise, this is actually good enough because we're just going to tell it to use this 3D location. The one drawback of doing it this way so far is that we don't get to know whether we've made the size of this tracker a good size, whether it actually goes and runs into something else later in the shot. So if we'd done offset tracking, then we would be able to see that relatively easily. In this case, we're going to do a little magic something instead, just using SynthEyes. We're going to say make tracker 12's location, its seed location, and make it outcome tracked. So basically what we're saying is that we want to take the seed location and we want to pretend that we've actually tracked it and obtained that particular location. And again, to make its outcome tracked, we're just saying, let's pretend we've tracked it. And we're going to do that for every frame.
Okay.
And just like that, now you see the time bar changes color. And now the claim is that it's tracked, even though we've just done something funny to it. So now if you look up here in the mini tracker view, you can double check and see if you've got something else creeping in, which we do. So you've got two different choices. One, you can either go back to the beginning and make it a little smaller, or you can go to the end and here make it a little smaller and create a key so that it stays the right size later on and gets to be larger earlier. And I'll point out, the larger the tracker is here, the more pixels there are in the interior, the lower the noise value is on that measurement. Now, probably once you get 100 or 200 pixels, that's going to be a plenty low enough error in the first place. But if you get it down to be super tiny, then your measurement is not going to be as accurate. You're going to just be seeing more compression noise and other shot noise and stuff coming out of the camera. So it is good to keep it a reasonably largish sort of size, and just to take a look and make sure that you don't have anything else coming into the picture that's going to mess things up. And here I'm just using a regular tracker. I'll point out you can also use a planar tracker. So I could do a planar track on the entire front part of the box, and then you can use an in-plane mask to exactly control what portion of the planar tracker, once you've tracked it, you can just set up an additional in-plane mask that you're going to have the interior of it measured, so you can achieve quite a bit of control that way. Just you could have some arbitrarily complicated shape if you needed to for some reason. So that's kind of a super sexy fallback position. But for what we've got so far, this is great. We've got our little rectangle of pixels to be measured. So we'll just lock that up for good measure. And we're ready to move on to our next step, which is to run a script that says set illumination from trackers. So it's got a bunch of different controls, as you can see. The most important one really is, what do we want to do with this illumination data? Once we've computed it, where's it going to go? So we're going to say we want to put it on light 1, and we'll just leave the other values alone. And SynthEyes points out there isn't something called light 1. Let's go ahead and create it. So now we can run to the graph editor, and let's just take a look at light 1. And now you see here's our illumination curves, RGB values for every frame as to what's happening at this particular location in the scene. So this is the raw extracted illumination data. It's been stored away on that light. Now we've got a bunch of different options available also, so let's take a look at that. So one of the things you notice is that, you know, the value doesn't ever come down all the way to zero. The scene itself, you know, you've got ambient illumination. So in a render, you'd have a light, you'd have some ambient illumination. The light you may want to have go all the way down to black at the darkest time. So you can actually subtract a value off here as you're generating the data. So now the values here are running from the low value up to a higher value. And similarly, you can now go and control what happens with those maximum values. So I could just go and, you know, manually say I want it to be 25% bigger. Or I could even go, let me take that away, and say I just want to auto scale. And so now it's scaling so that the value goes up to 1 exactly at the very, very top. So it's just giving you some simple capability to rescale the illumination data that you're pulling out of the scene to, you know, a set of values that may be more convenient to work with in your 3D application later. So a similar, or not similar, but additional set of controls. Let me just run that down. We can go and run it again, and let's just have it generate the data every 10 frames. So if you want to have some smoother curves, this is a way to get it. You know, if you've got an exact measurement and it's bouncing around some and you don't really need that, you may just want to do what I've done here. Now I can set them to smooth keys and have some nice smooth values rather than something that's changing on each and every last little frame. So you do have control over those parameters. So let's just put these back for a second. You notice there are some additional things. We could set it to monochrome. We could use the 2D or the 3D position of the tracker. You can set, you know, over the entire frame range, you know, just the playback range, or just even on a single frame if you want. So again, just a bunch of particular parameters. And one other point on this is too that if you select a bunch of trackers that you have set up right, it'll take the average of the selected trackers when you run this script. So let's run that and consider over here in our actual perspective view, let's go here and right now our mesh is coming out black because the light is sitting behind it. So, you know, we could go and move that out into some more sensible location to get that to come out to a better color. But we're also seeing the effect of this thing is dark in the first place. So literally with the light being the thing that changes, we want to have the object there be white. And, you know, now it's the coloration of the light that we're seeing on the mesh itself. But, you know, for this particular example, where here we're trying to track what's happening on the side of the box directly, you know, ultimately ask, well, why don't we just worry about computing what the color of the box is rather than worry about the light? And that makes perfect sense. If So if you've got a shot with, the explosions or strobes, stuff like that where the light's changing, then you do what we just did. You compute what's happening with the light. You put the light at the right location in the scene. If you're going to be dealing with a situation like this where you're trying to match the mesh itself, then it's better off to do this, which is to go and set the illumination curve for the light or for the mesh itself. So now you see we've got the mesh itself has that illumination curve on it. And in this case, to get the right thing, we want to, let's just get rid of that, and we want to select the keys for the light and get rid of them because we want the light to, in this case, we want the light to stay white. We want now to be using the illumination curves off of the mesh itself. So now we're getting the mesh to actually directly follow the measured value from this particular portion of the mesh. So here you'll see that the object isn't completely homogeneous. Probably we should scale it down a little bit and feather those edges a bit so that there's not such a sharp demarcation. And we need to have some noise added to it as well to match it. But the point is that we're directly getting that. And also the other thing we may even want to do is that. Turn that light off. So, here now we've got the mesh with the exact set of measured illumination curves, the measured colors that we can use to set up our downstream rendering. So, here we're doing the entire mesh, and the lighting across the entire mesh isn't exactly homogeneous. The corners are a little bit different. So if we wanted to, measure each of those corners, we could do that. And the thing that actually makes sense is to put a tracker at each of those locations. And when you run the script, the other thing that you can do is just take out that tracker or the target name altogether. And when you do that, it just writes the tracker itself. So now you've got the illumination curve in yet a different place. So the script is flexible. It lets you store the illumination data in 3 different kinds of places: on the mesh, on the light, or on the trackers. And one other thing I'll point out, here's the illumination data. It's being used to drive the display in the various viewports, but there are kind of different colors available to play with. If you look in the hierarchy view over here, these are just the little swatches, and the swatches are showing you basically the static, non-animated color at all times. So that's just used for simple exports and display of little things in the user interface. These swatches aren't the animated color. If you go to the 3D panel and scrub through, you'll see that the swatch here does show the full animated color, and you can go and change it if you're really so inclined from there to set it on individual frames. When there's no illumination curve at all for an object, if I go to a different tracker, say, then you just see the static color, the same swatch color that you see over there is here. So you only see the animated swatch if there is one, which makes sense. So another spot I'll point out too, you can always change the colors on any particular frame, just by double clicking in the number zone area over here. So it's a pretty nifty process. It's just a way of getting more data and getting it to you. You know, the next step from this process is to be able to export the data. The FilmBox exporter is the one that currently exports this data as an integrated part of its export. So for the meshes, for the lights, for the trackers. You know, of course, as with everything with FilmBox, what the downstream application does with that data, you know, remains to be seen. But, you know, for main applications like Maya, you should be able to get those color curves and then be able to mess with them further and use them within that environment. So if you're doing a light, you're still going to probably want to have some additional adjustments on the light, but the point is you can get out the fine details of what the light is doing during the shot exactly without having to try and guess at it and hand animate it later. So, and the one other spot I'll point out, another export that is available is just that there is a plain text export for the illumination data as well. So it just lets you select one of these different kinds of objects, a tracker, a mesh, or a light that has illumination animation on it, and just export that as a plain text file, which you can then read in to whatever sort of application you want. I think a lot of things will deal with some plain text. So I think it's a pretty cool tool that lets you get access to another kind of data that really is a pain to get otherwise. So hopefully it'll help you all out. Thanks for watching.